A thin cylindrical shell of diameter d and wall thickness t is subjected to an internal pressure of P. What would be the volumetric strain? We have to find out the volumetric strain. If E is the Young's modulus of elasticity and mu is Poisson's ratio of that cylindrical material, the material properties were given as E and mu. So we know the volumetric strain is PD by 4 plus E into 5 minus 4 mu. So option PD by 4 plus E into 5 minus 4 mu. Option C is correct. Here, for a fixed beam, from the moment distribution method, we can calculate the moment at this end, MFAB. MFAB for a fixed beam of length of equal length having L and central moment is of M. So M by 4 is going to be at MFAB. So option C is correct. Is a smooth backed vertical wall of 6 meter high and retaining soil with a bulk unit weight is given as 20 and phi is given as 20. The top of the soil, that is the backfill soil inclination with the horizontal is 0. If the soil surface carries a UDL of 50 kN per square meter is given, find the total thrust on wall per meter run. We have to find out. If you draw the diagram, it is a wall with an UDL on top 50 kN per square meter. So the backfill soil property is given as 20 degrees phi value, gamma is given as 20 kilonewton per cubic meter. If you calculate the K, activate the pressure coefficient 1 minus sine phi by 1 plus sine phi, that is equal to 0.49. Pressure due to soil and pressure due to external load. Pressure due to soil and pressure due to external load is going to be there. So it is an UDL. So the equivalent head due to UDL is equal to 50 by 20, that is equal to 2.5 meters. So the pressure is P1 is equal to Ka gamma H, that is equal to 0.49, 20 into 2.5, that is 24.5 kilonewtons per square meter. And equivalent height of the wall at the base of wall. Equivalent height of wall at base is equal to 6 plus 2.5, that is 8.5 meters. So what we have to find total thrust, that is equal to pressure at base. We will find out first, that is 0.49 into 20 into 8.5, that is equal to 83.3 kilonewtons. Total thrust per running meter is equal to 24.5 into 6 plus half, 83.3 minus 24.5 into 6, that is equal to 323.4 kilonewtons. So option A is correct. The question is, what is the value of minimum reinforcement in case of FE415 in slabs has to provide? So based on IS 456 2000, IS 456 2000, the minimum reinforcement for the slabs has to provide is 0.15%. So option C is correct. Reason for providing a number of reinforcement bars at a support in a simply supported beam is to resist in the zone the stresses developed due to bond. So the number of reinforcement bars we are providing in a simply supported beam to resist the bond stresses. So option C is correct. Is the velocity distribution of a flow fluid with viscosity of 0.8 Newton second per square meter is given by velocity distribution is given by this equation v is equal to 3y square. Then the shear stress at y is equal to 0.5 meter. We have to find out the shear stress at y is equal to 0.5. We know the shear stress is equal to tau is equal to mu into du by dy. So du by dy or dv by dy is equal to 3 minus 6y. Y is equal to 0.5. dv by dy at 0.5 is equal to 3 minus 3, that is equal to 3. By substituting this value in this equation 1, tau is equal to mu into dy at 0.5 is 0, that is equal to 0. So option A is correct. So the question is, water flows in a channel with 1 meter depth and velocity is given as 2 meters per second. An elementary wave can travel upstream with velocity of, we have to find out the velocity of wave, that is equal to relative velocity, we can say. So v absolute minus v of, if you substitute the depth and the velocity v of over here, you will get the value of 1.132 meters per second. So option D is correct. And is, in a basin, 6 rain gauge stations are reporting a rainfall in a year. So these are the 6 rain gauge stations which are reporting the rainfall for an year. The annual rainfall recorded by the gauges are given in the following table. So what we have to find out, the optimum number of rain gauges in the basin for 8% of error in estimating the mean rainfall. When an error of 8% is occurring in estimating the mean rainfall, what are the number of rain gauges that are required? We know n is equal to, number of rain gauges is equal to CV by percentage of error whole square, where epsilon is equal to 8%. We know CV we have to find out, that is standard deviation by x bar, mean, into 100. Standard deviation we have to calculate, that is sigma x minus x bar whole square by number of gauges minus 1, that is equal to, if you substitute all the values, 12.28 you will get. CV is equal to 12.28. The average of the rain is 49.5 rainfall, that is into 100, that is equal to 24.81. CV we know, epsilon we know, so the number of rain gauges n is equal to 24.81 divided by 8% whole square, that is equal to 9.62 approximately is equal to 10. So option D is correct.